Okay, now that we've completed our first least squares regression equation, there's some more information we need from the technology or from Desmos. And so we now use it to make a prediction of someone's history score if we knew what their English score was. What becomes important is how strong is this relationship? Can we really use the English score to predict history scores? And the best way to do that is to measure the strength of the relationship. So you can see when the points are lined up better, that's a stronger relationship versus when they're kind of scattered, but still kind of some pattern here. And so in either way, we're considering which is a stronger relationship, meaning that those variables are related, probably the more likely related in some way. And in order to measure that, we look for something called the correlation coefficient. It's a way to measure the strength and direction of a linear relationship, how the two variables are related. And here are some rules with it. So when we say a positive relationship, the values are going up versus a negative relationship when the values are going down. And so looking at these, again, these rules here, if the value, your correlation coefficient is equal to 0, then we say there's a weak relationship or no relationship. And so looking at that, what are we talking about is this R value, this correlation coefficient appears when we ran that least squares regression in for this data we had. You can see the R value comes up. It's right there. R equals 0.9162. Now, again, what does that number mean? It depends on its value, right? It's going to always be a number between -1 and 1. It's positive, which means we have a positive relationship. The values are going up. And then the idea, if it's closer to 1 or -1, we have a really good fit, right? It means that the values are related in a linear regression. And so just to give you some practice here, match these values. Here are some values here are some scatter plots. It's already matched them up for you with their R values, and what we're really looking for is kind of the direction, right? There's a line here. This one's coming down, so it's negative. This one's kind of scattered, so it's hard to see. It's a little bit more spread out, the data. So these values are closer to 1 or -1. This is really scattered out, so it's hard to see that relationship. This one has one here. This is really kind of just scattered out, so you get very weak relationship. So that's called the correlation coefficient. That helps us gauge how strong, what type of relationship we have and how strong it is. So I want to make sure you're aware of that there.